So hey guys, a very good day to you all. In this video, we will understand the Arrhenius theory, then we will understand the Bronsted-Lowry theory, and in the end, we will understand the Lewis theory. Now basically, the use of all three theory is to help us distinguish between a acid and base. So let us start with the first theory, that is the Arrhenius theory. Arrhenius theory. The main motive of this Arrhenius theory is to help us distinguish between a acid and a base. Okay, so let's see what Arrhenius theory has to tell us. It says that acid is nothing but a substance which contains hydrogen and produces H plus ions when dissolved in water. So if any substance has hydrogen in it and after dissolving it in water, if it is giving out H plus ions, then it is an acid. For example, HCl, your hydrochloric acid. If you dissolve hydrochloric acid in water, it is going to give you H plus ions plus Cl minus ions. And the main requirement for an acid is that after dissolving in water, it must give us H plus ions. So since HCl is giving us H plus ions when dissolved in water, therefore HCl becomes your acid. The next example is the acetic acid, CH3COOH. So when you dissolve this acetic acid in water, it is going to give us CH3COO minus ion plus H plus ion. So here also you can see that this acetic acid is giving us H plus ions, and as it is giving us H plus ions after dissolving it in water, therefore your acetic acid becomes a acid. Now this H plus ions that we are getting will be hydrated in water. Okay, so it will get hydrated because of the water molecules, and it will not be present as H plus ions. Instead, they will be present in the hydrated form, that is H3O plus, H5O2 plus, H7O2 plus. Now you might be wondering, how do we get this hydrated form? As mentioned earlier, these H plus molecules will combine with water molecules. Okay, so when you add a H2O to this H plus, you are obviously going to get H3O plus. As you can see over here, H2O plus H plus will give you H3O plus. And if you add one more water molecule to this H3O plus, you are obviously going to get H5O2. So if you add H2O to this H3O plus, you are going to get H5O2 plus. Similarly, if you add another water molecule to this H5O2 plus, then you are obviously going to get H7O2 plus. Okay, so these are just the hydrated forms of H plus ions. So H plus ions are not going to be present in water as H plus ions, but instead they will present in the hydrated form. Now on the basis of this, we have three different types of acids: the monobasic acid, the dibasic acid, and the tribasic acid. Now what are these different types? First of all, the monobasic acid is nothing but an acid which gives out one H plus ion after dissociation. For example, if you consider a molecule of HNO3, so when HNO3 is dissolved in water, it is going to get dissociated, and after getting dissociated, it is going to give us one H plus ion. Similarly, a dibasic acid is nothing but an acid which gives us two hydrogen H plus ions after dissociation. Okay, so when you dissociate H2SO4 by adding it in water, it is going to give us two H plus ions. Similarly, you might have guessed what is a tribasic acid. A tribasic acid is nothing but an acid which gives us three H plus ions after dissociation. Okay, now moving ahead, let's now understand what is a base. So we have understood how to identify an acid. Now it is time for us to understand how to identify a base. So Arrhenius theory tells us that A base is nothing but a substance that contains OH group. Okay, so any substance containing OH group, that is this group OH, and produces OH minus ions when dissolved in water is called as a base. Like in the acid, we had a substance which has hydrogen in it. Here in the base, we have a substance that contains OH in it, and after dissociation it will give away OH minus ions. For example, let's consider NaOH, the sodium hydroxide. So when you add this sodium hydroxide to water, it is going to get dissociated into Na plus and OH minus ions. So can you see over here, we are getting OH minus ions, and since we are getting OH minus ions, therefore this NaOH becomes your base. So I hope it was quite easy for you all to understand. Now again guys, this OH minus ions will not be present as OH minus in aqueous solution which contains water. So again, this OH minus ions will get combined with water molecules. As we all know that we are adding this NaOH to water, so water is our solvent. So this OH minus ions will combine with water molecules and will present in the hydrated forms as H3O2 minus, H7O4 minus, and H5O3 minus. And I hope you all know how we get this hydrated forms by simply adding H2O to it. So if you add a H2O to this OH minus, you are obviously going to get H3O2 minus. You can add, see, OH contains one hydrogen and H2O contains two hydrogens. So 1 plus 2, 3. So we have 3 hydrogens over here, and OH contains one oxygen atom and H2O contains one oxygen atom. So 1 plus 1 gives you 2. So that's why we get H3O2 minus. Similarly, if you add one more water molecule to this H3O2 minus, you are going to get H5O3 minus. And if you add one more water molecule to this H5O3 minus, you are obviously going to get H7O4 minus. So this is how your base is identified with the help of the Arrhenius theory. Now, moving on, just like the acids, we have 3 types of base: the monoacidic base, the diacidic base, and the triacidic base. Now, what is a monoacidic base? A monoacidic base is nothing but a base which gives us one OH minus ion after dissociation. For example, your cesium hydroxide. So when your cesium hydroxide is added in water, it is going to get dissociated and will give us one OH minus ion. Similarly, a diacidic base, a diacidic base is nothing but a base which gives us 2 OH minus ions after dissociation, like your barium hydroxide. So when your barium hydroxide is added to water, it is going to give us 2 OH minus ions. Similarly, a triacidic base, FeOH3, is going to give us 3 OH minus ions after you add it to water. So I hope you have understood these types as well. Now, although Arrhenius theory accounts for properties of many acids and base, it has certain drawbacks, or you can say it has certain limitations. For instance, the theory is applicable to aqueous solutions. As you have seen, we were adding the acid and base to water. So this theory is applicable to aqueous solution. Aqueous solution is nothing but a solution where water is a solvent. And it does not account for the basicity of substances like NH3, Na2O3, etc., which do not contain OH groups. Now, what is the meaning of this? See, NH3 is a base. Na2CO3 is also a base. But what Arrhenius told is that a base is a substance which contains OH group. But these two substances, although being a base, do not contain OH groups. So hence, the Arrhenius theory was not applicable for all substances. So therefore, a next theory was developed, that is the Bronsted-Lowry theory. So after understanding the Arrhenius theory and its drawbacks, now it is time for us to understand the Bronsted-Lowry theory. And in order to understand this theory, let's move on to my book. Okay, so according to the Bronsted-Lowry theory, acid is a substance which is going to donate proton, whereas a base is a substance which is going to accept proton. Now you might be wondering how the acid and base is going to donate and accept proton. So they are going to do this in the form of H plus ions. Let's see how. So let us consider a hydrogen atom which has only one proton in the nucleus, and it does not have a neutron, as we all know, and it has one electron in its shell. Okay, now so a hydrogen atom has one proton and one electron. Am I right? Now what we are going to do is that we are going to remove this electron. So if we remove this electron, we are going to be left with only one proton which is present in the nucleus, and there will be no electron in the energy level. So this is nothing but known as the H plus ion, and this is nothing but your hydrogen atom. So when you remove one electron from hydrogen atom, you are going to get a H plus ion. Now guys, can I say that this H plus ion is equivalent to the one proton? Why? Because this H plus ion has only one proton. Okay, so the acid and base are going to donate and accept protons in the form of H plus ions. They cannot directly accept or donate a proton which is present in the nucleus, but instead they are going to do it in the form of H plus ion, because H plus ion is equivalent to a proton. I have explained you all this now. Okay, now let's understand how they are going to donate and accept with the help of a reaction. So let us consider a reaction, HCl reacting with NH3, and it is a reversible reaction giving us NH4 plus Cl minus. Okay, now if you observe this reaction carefully, can I say over here guys that this NH3 after the reaction is getting converted into NH4 plus, and when it is getting converted into NH4 plus sorry guys, and when it is getting converted into NH4 plus, can we see that it is accepting H plus ion? Can you see over here? If you add a H plus ion to this NH3, it is going to get converted into NH4 plus. So after accepting an H plus ion, this NH3 is getting converted into NH4. Whereas, can you see over here, this HCl is getting converted into Cl minus, and while it is getting converted from HCl to Cl minus, can we say that it is donating H plus ion? Why it is donating H plus ion? Because can you see over here, from this HCl, this H is removed and getting turned into Cl, and since Cl is carrying a minus charge, therefore not only H but H plus charge is being donated by this HCl and got converted into Cl minus. Now let me write this equation once again. So this HCl reacting with ammonia and getting converted into NH4 plus Cl minus. Now see, this HCl is donating H plus ion, and who donates H plus ion? It is nothing but a acid that is going to donate a proton. And how are going to donate proton? In the form of H plus ion. And here you can see that HCl is donating a H plus ion. So can I say that HCl ultimately becomes your acid? Why? Because donating an H plus ion is equivalent to donating a 1 proton, and the one substance which donates a proton is nothing but a acid. So your HCl is going to be a acid. Similarly, NH3 is accepting H plus ion, and when it is accepting an H plus ion, can we say it is equivalent to accepting 1 proton? Okay. Now, since it is equivalent to accepting a proton, and who accepts a proton? A base is going to accept a proton. So ultimately your NH3 is going to be a base. Okay. Now watch carefully, guys. This reaction is a reversible reaction, which means that there is forward reaction present as well as reversible reaction present. First, the reactants are going to turn into products, and the products are going to turn back into reactants. Okay, so now let us see what is going to happen in a reversible reaction where these products are going to turn into reactants. Okay, so let us write our reaction. HCl plus NH3 is a reversible reaction giving us NH4 plus Cl minus. Now we are going to understand the changes in the reverse reaction, where the NH4 plus is going to react with Cl minus to give back HCl and NH3. Okay, now guys, can I say over here this NH4 plus is reacting back to give us NH3? Am I right? This NH4 plus is going to get converted into NH3, and while it is getting converted from NH4 plus to NH3, can I say, guys, it is donating H plus ion? Can you see over here? If you remove an H plus ion from this NH4 plus, you are going to get NH3. Okay. Similarly, if you observe, this Cl minus is getting converted into HCl, as you can see over here. Okay, so the Cl minus is getting converted into HCl, and while it is getting converted from Cl minus to HCl, can I say, guys, that it is accepting an H plus ion? Can you see? If you add an H plus ion to this Cl minus, what you are going to get? You are going to get HCl. Okay, so here can I say that the H plus ion donated by this NH4 plus is accepted by this Cl minus? Similarly, here also the H plus ion donated by HCl is accepted by NH3. Okay, now here let me write this equation once again. Now since this NH4 is donating, NH4 plus is donating H plus ion, can I say it is donating an proton? Because donating an H plus ion is equivalent to donating a proton. And who donates a proton? It is nothing but a acid which donates proton. So here we are going to say that this NH4 plus becomes your acid. Similarly, guys, this Cl minus is accepting H plus ions and turning into HCl, and accepting H plus ion is equivalent to accepting a proton. And who accepts proton? It is the base that is going to accept a proton. So can I say that this Cl minus is nothing but your base, and we had already got to know that this HCl and NH3 are acid and base. So let me write this again here. Now on the product side, we do not directly write as acid and base. Instead, we write it as conjugate acid and a conjugate base. Now why do we write so? Now see, make observation over here. See, can you see over here, this NH3 is getting converted into NH4 plus. Okay, so NH3 is getting converted into NH4 plus, and the same NH4 plus is again getting converted into NH3. So as there is a relation between both of them, therefore we say that these both are conjugate acid base pair. They are conjugate acid base pair. Similarly, if you see over here, this HCl is getting converted into Cl minus, and again this Cl minus is getting converted into HCl. So since there is a real relation between both of them, therefore they are also called as a conjugated acid base pair. So in the reaction here we are having two conjugated acid base pairs. One is the NH3 and NH4 plus, and another one is HCl and Cl minus. So there are two conjugated acid base pairs present over here. Okay, so this was all about your Bronsted-Lowry theory. Okay, now here, if you want to make sure whether your conjugated pairs are right or wrong, I have a tip for you all. Okay, conjugate acid base pair differ by only one proton, that is nothing but H plus ion. Okay, let's check. Let's consider any conjugate acid base pair. Let's consider HCl and Cl minus. HCl and Cl minus, they both are conjugated acid base pair. Now if you see over here, they both of them are differing by one H plus ion. How? If you remove an H plus ion from Cl, it is going to get converted into Cl minus, and if you add a H plus ion to Cl minus, it is going to get converted into HCl. I knew I went fast, right? Let me repeat myself again. See, this HCl and Cl minus are differing by one proton, that is one H plus. How? See, if you add H plus to this Cl minus, it is going to get converted into HCl. Similarly, if you remove an H plus from this HCl, it is going to get converted into Cl minus. So can I say that there is only a difference of one H plus between the conjugate acid base pair? Similarly, you can check for another conjugate acid base pair, that is NH3 and NH4 plus. It is pretty much clear that if you add H plus ion to this NH3, it is going to get converted to NH4 plus, and if you remove an H plus ion from this NH4 plus, you are going to get NH3. So there is just a difference of one proton, and you can verify your answer. Now, okay, this part was okay, everything was fine up till here. Now here you need to understand something. Let us see this reaction over here, where this HCl is reacting with H2O to give us H3O plus Cl minus. Okay, now see, this HCl is getting converted into Cl minus. HCl getting converted into Cl minus. So while it is getting converted from HCl to Cl minus, can you see over here, it is donating a H plus ion. And who donates an H plus ion? It is obviously a acid that donates H plus ion. Similarly, if you observe this H2O, this H2O is getting converted into H3O plus, and when it is getting converted from H2O to H3O plus, can we say that one H plus ion is getting added to it. So this is going to accept the H plus ion. And who accepts H plus ion? It is the base that accepts the H plus ion. Similarly, in the reverse reaction, what is going to happen in the reverse reaction? The Cl minus is going to get converted into HCl, and while it is getting converted from Cl minus to HCl, can I say it is going to accept an H plus ion? And who accepts H plus ion? It is nothing but a base which accepts the H plus ion. But since it is on the product side and we want to form the pairs, we write it as conjugated base. Now, here automatically this becomes your acid, your conjugated acid, or you can, let's see whether it is true or not. This H3O plus is getting converted into H2O, and while it is getting converted from H3O plus to H2O, can you see over here guys that it is going to donate one H plus ion? That is, if you subtract one H plus ion from this H3O plus, it is going to get converted into H2O. Okay, so this becomes your conjugated acid. Now, what I want you to observe over here is that here H2O is acting as a base. Now let us consider another equation where this NH3 is going to react with H2O to give us a reversible reaction, NH4 plus OH minus. Now in this reaction, can we see over here this NH3 is getting converted into NH4 plus, and when this NH3 is getting converted into NH4 plus, can we say that it is accepting one H plus ion? So since it is accepting an H plus ion, it becomes your base, as this H2O is getting converted into OH minus, and when this H2O is getting converted into OH minus, can I say guys it is donating one H plus ion, and since it is donating one H plus ions, it is getting converted into OH minus. So this becomes your acid because it is donating a H plus ion. And here you can easily find out that this is your conjugated. It is getting converted from NH4 plus to NH3. So here it is donating a H plus ion, so it becomes your conjugated acid. Whereas here OH minus getting converted into H2O is accepting a H plus ion, getting converted into conjugated base. Okay. Now here H2O is acting as an acid, whereas in this equation H2O is acting as a base. So such substances which acts like a base as well as acid are called as amphoteric substances or amphiprotic substances. Okay, so the substances which acts like a acid as well as base are called as amphoteric substances or amphiprotic substances. Okay, so although Bronsted-Lowry theory is broader than Arrhenius theory, which we have studied earlier, it also emphasizes the presence of hydrogen in an acid like the Arrhenius theory. However, it could not only explain all the Arrhenius acids and bases, but includes many more substances as acids and bases like the conjugated acids and the conjugated base. So it was obvious that the Bronsted-Lowry theory was more broader than the Arrhenius theory. But after Bronsted-Lowry theory, in the same year 1923, one more broader theory was proposed, that is nothing but the Lewis theory. Okay, so what Lewis theory tells us that acid is a substance which accepts a share in an electron pair. Now what is the meaning of this? Guys, just give patience for next 3 to 4 minutes and I will explain you all everything. Okay, so just understand the basic points, that acid is nothing but a substance which accepts a share in an electron pair, and a base is nothing but a substance which donates a share in an electron pair. Now let us understand this with the help of an example. Let's say H plus reacting with NH3 gives us NH4 plus. Now let us draw the dot and cross diagrams of this equation. So H plus combines with NH3. Nitrogen has 5 electrons in its outermost energy level, as we all know. Okay, so let me draw the 5 electrons over here, and this nitrogen is combining with 3 hydrogen atoms. So it is going to form a bond with 3 hydrogen atoms, and each hydrogen atom is sharing 1 electron. So while forming a bond with nitrogen, 1 electron is being shared by nitrogen and 1 electron is shared by hydrogen. So this is how they form a bond. Now this nitrogen has 2 free electrons. Okay, so they are not bonded to any of the atom, they are free. Now what happens is that after reaction, this H plus requires electrons. Why it requires electrons? Because it is positively charged. So since it requires electrons, it is going to take these 2 electrons of nitrogen. And why it is going to take both these electrons? Because H plus does not have any electron in it, and to form a covalent bond you require minimum 2 electrons. So this nitrogen is going to donate its 2 electron to form a covalent bond. Let's see how. So nitrogen is going to form a covalent bond, and this hydrogen bond, the side hydrogen bond and the lower hydrogen bond. Now as you can see, in each bond, each of these bond, one electron is being shared by nitrogen and 1 electron is being shared by hydrogen. But only in the case of this bond, which is nothing but a coordinate bond, both the electrons, the 2 electrons required for forming a covalent bond, are being shared by nitrogen only. The hydrogen is only accepting a share in an electron pair. It is accepting a share in an electron pair, whereas this nitrogen, this NH3, complete NH3, is donating a share in an electron pair to H. Can you see? Both these electrons are being shared by this NH3, this N. Okay, so here, since this H plus is accepting a share in an electron pair, this H plus becomes your acid. Whereas this NH3, this complete NH3 is donates a share in an electron pair. It is donating a share to this H plus in an electron pair. Therefore this becomes your base. Okay, so this is how Lewis theory tells us that acid accepts a share in an electron pair and the base donates a share in an electron pair. Now similarly, let us consider one more example to understand in a much more better way. And guys, let me tell you all, the complete charge on this compound formed will be plus. Why plus? Because this H plus is combining with this NH3. So when a compound is formed, the plus charge will get to the complete compound. Now, moving on, let's understand another example where BF3 combines with NH3 to give us BF3 and NH3. Now let's see how. Okay, so let me draw the diagrams over here. So for BF3 we have a boron over here. Okay, boron has 3 electrons in its outermost shell. So let me draw these 3 electrons. Whereas this fluorine has 7 electrons, so it is going to combine. Fluorine requires 1 more electron, so it is going to combine with boron. Okay, and this is how 1 electron will be shared by fluorine and 1 electron will be shared by boron. This is how a covalent bond is formed between them. But if you observe carefully, now also guys, this boron has only 6 electrons, 1, 2, 3, 4, 5 and 6. But it requires 8 electrons to complete its octet. Although it is sharing 3 more electrons, but 3 plus 3 is giving him only 6. It requires minimum 8 electrons to complete the octet. So it is obvious that it requires plus 2 electrons. So what it is going to do? It is going to combine with NH3. Nitrogen has 5 electrons in its outermost shell. Okay, now it is going to combine with H and H, 3 hydrogens. Can you see over here? And it is going to form a bond. So here also, if you see, 1 electron is being shared by hydrogen and 1 electron is being shared by nitrogen in all 3 bonds. And it has 2 free electrons, electron pair. Okay, so this boron requires 2 electrons to complete its octet, but it cannot contribute any electron to this NH3 because its all 3 electrons are already covalently bonded to F. So what is going to happen over here? This NH3 is going to share its electron pair, and this is how a bond is going to get formed. This F, I am drawing the diagram as it is, and this N is going to share a covalent bond, coordinate bond, my bad. It is going to share a coordinate bond, and this is your compound formed. So if you see, in both the cases there is a involvement of coordinate bond. And what is a coordinate bond? A coordinate bond is a bond where both the electrons are being shared by one compound. Okay, now here can I say that this BF3 is accepting a electron share pair, and one which accepts a share in an electron pair is nothing but your acid, and the one which donates a share in an electron pair, this is donating. Okay, NH3 is donating its electron pair, share in electron pair. Therefore this becomes your base and it is forming a new substance. So this is how you find out the base and acid with the help of the Lewis theory. So this theory emphasizes the formation of coordinate covalent bond. Can you see? It emphasizes on formation of coordinates covalent bond. So as this was all about the Lewis theory, I hope you have understood this topic and liked this video as well. So guys, do check out my channel where I have uploaded physics and chemistry videos of class 11th and 12th. They might be helpful for you all. And thank you for watching this video.